Hello, today we will be looking at 6.6, finding rational zeros. And as you noticed, the calculator is up on the screen, so I want to make sure that you have your calculator out. If you don't, press pause and get it out. Alright, so what we're going to do is we're going to be finding all real zeros right now. And the key word here is real. We know that we can have imaginary solutions, we know that we can have real solutions. Since the degree is 3, we know that we're going to have 3 solutions total. But that doesn't mean that I'm going to have 3 real solutions. So what we're going to do is we are going to find all possible real solutions. In this case, I'm not giving you any solutions. Up until now, when I gave you an equation, I gave you one of the solutions that you had to use synthetic division and factor out. So as you see, when you aren't given one, look at your calculator to find one. So think about it. If I'm looking at my graph on my calculator, where would I see a real zero at? Where would I see a real root? Well, we know that 0 is the same thing as a root, which is the same thing as an x-intercept. So we go ahead, we press our y equals, we enter our equation in, x to the third minus 4x squared minus 11x plus 30. And notice that I have it set equal to 0. Remember, we're trying to find where this graph crosses the x-axis, so we've got to plug 0 into y2. If you don't plug 0 into y2, you're not going to be able to find a 0. Go ahead and press graph. And we know that we should expect to find at most 3 solutions, because we've got x to the third, that's our degree, and we can see that we have 1, 2, 3 x-intercepts. So I actually know in this case that I'm going to have 3 real solutions. Now we're not going to go and find the intersection point, because I'm just going to guess right now. If I look at my graph, -1, -2, -3, I'm guessing that there is a solution at a -3. So I'm going to use synthetic division and factor that out. 1, -4, -11. We're writing down our coefficients. We don't have any missing terms, so don't have to worry about filling in zeros. Bring down the 1, -3 times 1 is a -3. Remember, with synthetic division, we just combine those to get a -7. We multiply to get a positive 21. That leaves us with a positive 10. Multiply, we get a -30. And the fact that I have a remainder of 0 means that I did find a solution. I did find that factor. Now, if you want to go ahead and section point to make sure that it's a solution, you can. Otherwise, finding the remainder of 0 is that kind of double checking step. Now, if you did not get a remainder of 0, that means that you guessed wrong and the number that you picked either isn't a solution or you did your synthetic division wrong. So we go ahead and we bring that down. Since we started with an x cubed, that means that we've got 1x squared minus 7x plus 10. And we look at this, we go ahead and try regular factoring. What two numbers multiply to a positive 10 and add to a -7? That's a -5 and a -2. So we know that we have a couple different things here. First, we can write our equation in factored form. And you just don't want to forget about that first factor that we found, or the first solution. If -3 is a solution, x plus 3 is a factor. And then we just factored our quadratic to find x minus 5 and x minus 2. Now we can take our factored form. When we set that equal to 0, we can find our solutions. And we find our solutions just by setting each piece equal to 0 and solving. Therefore, we've got x is equal to a -3, which we found on our calculator, x is equal to a positive 5, and x is equal to a positive 2. So we found our 3 real solutions for our first problem. When we look at our second one, we've got f of x is equal to 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. So we know that here we can have at most 4 real solutions. So we go ahead and plug that back in. 2x to the fourth plus 7x to the third minus 4x squared minus 27x minus 18. Now make sure that you go back and double check. The longer the equations get, the more likely you are to enter a number incorrectly. So always double check the equation in your calculator and make sure that you didn't press a wrong button, a minus when it should have been a plus, and so forth. Alright, so we go ahead and graph that. Now I can definitely see that there's a solution here, here, and then when I look at the middle, I don't know if that's one or two solutions. Since we're not zoomed in far enough, I don't know if that's crossing once or twice. So we go ahead and start with what we know. 1, 2, 3. I think that there's a solution at negative 3. Again, you can go ahead in the calculator and you could find the intercept and double check, but I'm going to double check using synthetic division. So 4, 3, 2, 1, 0. We're not missing any pieces. We bring down the 2. Negative 3 times 2 is a negative 6. That becomes a positive 1. We multiply to get a negative 3. That leaves us with a negative 7. We multiply to get a positive 21. We combine to get a negative 6. Multiply to get a positive 18. And again, we have our remainder of 0, so we know that negative 3 is a solution. And we are finding that from our calculator. Don't forget that's where the negative 3 comes from. Alright, so we factored out one solution. We started with a 4th degree. Now we have a 3rd degree left. So this is 2x to the 3rd plus x squared minus 7x minus 6. If we have 4 pieces, we know that our only option for factoring would be factoring by grouping. So we group the first 2, we group the second 2, pull out our GCF of an x squared, we're left with 2x plus 1. Pull out a negative 1, we're left with 7x plus 6. We see that the insides don't match, so we can't factor by grouping. If we can't factor by grouping, that means that we can't factor that 3rd degree polynomial by hand. That does not mean that we can't factor any further. If we look back at our graph, again, the middle we're not quite sure about, but if I look, it looks like I have a solution at 2. So I'm going to go ahead and try using synthetic division again with the 2. We are left with 2, 1, negative 7, negative 6. So I'm going to use those numbers. Remember, the 6 would be our remainder. There is no remainder. I bring down the 2. I multiply, that gives me 4. I add those together. 2 times 5 is 10. Add, we get 3. Multiply, we get 6. And again, a remainder of 0, proving that 2 is going to be a solution. So that's going to leave us with 2x squared plus 5x plus 3. Now we're left with a quadratic. We have to be able to factor. If we can't factor, then we're factored as far as we can go. So we go ahead and check that out. We have to do Batman here since there's no GCF and our A term is not 1. Bring down the first and the last. We're looking for two numbers that multiply to 6 and add to 5, which is a 2x and a 3x. We use our factor by grouping here. Pull out the 2x. We're left with x plus 1. Pull out a 3. We're left with x plus 1. And notice how this factoring by grouping works since we have x plus 1 inside of both pieces. We take the GCFs together, 2x plus 3 as our first factor and x plus 1 as our second factor. Alright, so now we go to factored form. We have to list all of our factors. We found negative 3 was a solution, which means x plus 3 is a factor. We also found in our calculator that 2 was a solution, which means x minus 2 is a factor. And then from our quadratic, we got 2x plus 3 and x plus 1. Then the very last step is to take this, find our solutions, we set that equal to 0. We set each piece equal to 0. Most of them are pretty easy. We know that we've got x is equal to a negative 3, x is equal to a positive 2. This one you may have to do by hand. We move the 3 over to get 2x is equal to a negative 3, divide by 2, to find that our third solution is a negative 3 halves, and then our last solution is a negative 1. Alright, so in our second problem we had a degree 4, which means we had at most 4 solutions, and we are lucky in the fact that they were all 4 real solutions. So that means that we must have had 2 intersection points at those x-intercepts. All right, go ahead and turn your sheet over. We've got one last problem. So in those first two, we were finding all real solutions. Now notice that it's changed just a little bit, and we are finding all possible solutions. So we have a fourth degree polynomial again, which means we're going to have 4 solutions. Remember, degree tells us how many solutions, not necessarily what kind of solutions they are, but how many solutions I'm going to have in the end. So we go ahead and plug this in, clear out that old equation. Make sure that once you're finished, you double check that you entered everything in correctly. Don't forget an X, don't forget a plus or a minus. Since all of this is done in the calculator, it's really hard to give any kind of partial credit if you enter an equation in incorrectly. So it's super important that you enter that equation in exactly how you see it. Alright, so we go ahead and press graph. When I press graph right now, I'm only seeing 2 solutions. 2 real solutions. Now that doesn't mean that there's not more. I could zoom out and see that we're going to cross several different times. But I'm going to go ahead and start with these. So I look -1, -2, -3, -4, -5. I think that my first solution is at a -5, so we go ahead and factor that out using synthetic division. 4, 3, 2, 1, 0. We double check and make sure that we're not missing any pieces, which we're not, which is good, so we don't have to fill any zeros in. Pull down the 1, that gives us -5, that's a -4, multiply to get 20, add to get 8, multiply to get -40, add to get -8, multiply to get a +40, with a remainder of 0. So we were correct in the fact that -5 was a solution. So this leaves us with x cubed minus 4x squared plus 8x minus 8. Again, we start with a 4th degree, so when we factored out one solution, we're now at a 3rd degree. We check to see if we can factor by grouping. We pull out x squared, we're left with x minus 4. We pull out an 8, we're left with x minus 1. So no, we can't factor by grouping here, which means we've got to go back to synthetic division. We look and we see that we have a solution, possible solution at 2. So we go ahead and synthetically divide out the 2 using the 1, -4, 8, -8 that we were left with from the first step. Pull down the 1, multiply to get 2, add to get -2, multiply to get a -4, add to get a +4, multiply to get a +8, which leaves again a remainder of 0, which means that 2 is a solution. This leaves us with x squared minus 2x plus 4. So we're looking for 2 numbers that multiply to 4 and add to a -2. Well, there are no 2 numbers that multiply to 4 and add to a -2. So at this point we're going to stop and we're going to go ahead and go into factored form. We found a solution at -5, which means we have a factor at x plus 5. We've got a solution at 2, which means we've got a factor at x minus 2. And last, our factor is x squared minus 2x plus 4. We couldn't factor that any further, so that's how we have to leave it. And we go ahead and start solving by setting it equal to 0. And we're going to set each piece equal to 0. So we've got our first one, x is equal to a -5, and x is equal to a +2. Now again, I would use the quadratic formula just because I think that's easiest. So we've got opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When we use the quadratic formula, we've got 2 plus or minus. On the inside, we're left with a -12 because 4 minus 16 all over 2. Now I can break down 12 into 4 and 3, 2 and 2. So that becomes 2 plus or minus 2i root 3 all over 2. Because we have the negative on the inside, we know that we're going to have imaginary solutions. Then I have 3 pieces. All 3 pieces are divisible by 2, which means that leaves me with 1 plus or minus I root 3. So those are also going to be solutions. 1 plus or minus I root 3. So we do have 4 solutions. We have 2 real solutions, which can be seen on our graph as x-intercepts, and we have 2 imaginary solutions. Remember, imaginary solutions cannot be seen on our graph. So we have our total of 4, 2 real, 2 imaginary. All right, and that's it for today.